Hi, everybody. So today we are going to look at topographic maps here of, well, we're going to look at Canada specifically, but like, what are these? So what a topographic map is, you can see here, like, this is pretty obvious what this represents, right? This represents the different elevations. For example, I can see, let me use my laser pointer. I can see this section right here, the red, is taller, a lot taller than the upper blue section here, right? The colors represent how tall something is. So our highest part of the province is this bottom left, and then it slowly gets lower and lower in elevation the further up we go. Not everything's color coded though, especially if you think back in the day. If you think a few hundred years ago when people were exploring America and Canada, we had these European settlers here. They were mapping stuff out. How do you draw a brand new map of a new place? A lot of that is topography, and there's some math involved with that, but we're not really getting into that. We're not doing the math behind it. We're learning how to read them, not necessarily how to make them. Okay. So the big thing you guys are going to need for this is you are going to need these bad boys. So these are, let me just do this so I can see a little bit. So these here, this is a Vancouver topographical map. Now, right now, this should make no sense to you. That's fine. Okay. This is a very high quality one. If I zoom in, for example, it's going to take a minute. There we go. So where I'm specifically looking at though are, sorry, it's such a large file size that it does this. Bear with me for 1 second. Yeah, that's the unfortunate part about using this. This is why I've given you guys a printed one. So here we go. So where we're specifically looking at are these lines here. You see this little brown line that goes. Each one of these lines is a 20-meter raise in elevation, right? So okay, I'm done with that. So going to the print-friendly version here. So if I go to this version here, this here is a map of North Vancouver, which is what we're going to be looking in. Now, for example, if I go right down here, this here where I'm highlighting is effectively like the coast, or rather like this part here is. But if I go up here, there's plus 20 meters. If I go, here's another one, here's 40 meters. If I go here, here's 60 meters. And then, if I keep going up and up and up and up and up and up and up, it just keeps going higher and higher and higher. You can see here, for example, again, this here's 20 meters, 20 meters, 20 meters, 20 meters. Now, if you're looking, this line right here, where I'm drawing these arrows to, it's a little bit bolder, right? This is representing a 100-meter raise. So here's the other one over here. So from this distance, this is plus 100 meters. And then every one of these ones in between, boom, 2, 3, 4, 5. This is 20, 20, 20, 20. So that's generally, and here's another 20. So that's generally how we read these things here, okay? So again, these maps show this elevation here. You're going to be using these maps. You're going to be drawn on these maps. But before that, there's going to be a couple notes for you guys. So make sure you guys get this information down. But so a topographical, and for that, anytime you guys see a slide, like I'll tell you, like write it down. For example, you'd write this down. So you'd pause the video, write it down, resume it. So 3, 2, 1, resume the video. So this gives you a way to do a detailed and accurate illustration of a man-made and natural features on the ground. Now, we're specifically only going to use it for elevation, but you can get incredibly detailed with this. Even people like power companies or internet, SaskTel, these people rely on these maps for their everyday jobs. And generally speaking, it's a 2D way of representing a 3D landscape. And again, they just show that elevation. So again, just going back to this fact here. So make sure you guys get this down. So pause the video, write this down. So there's a couple things here. So again, we're not going into all of this. This is deeper than the scope of the class, but we're looking into the relief. So relief is mountains, valleys, slopes, depressions. You saw that word. I used that word last assignment. That is a vertical change. You can have ones for the hydrography, right? Which is the water, the vegetation, the transportation. You can have stuff with culture. So that's our buildings, that's our pipelines, that's our power lines, that's our internet lines, stuff like that. That's our gas lines. You can have boundaries, borders between between nations, between cities, between jurisdictions, between properties, even, and you can have toponymy, which is the names of places. So all of these things will usually be present on a modern map, but then you can filter it for certain things. For example, maybe I only care about the pipelines of the city. I would go to that. So it's a bunch of blueprints overlaid on top of one each other. So um, if you look at like a map, for example, again, not really relevant to us, but different colors usually show different things. But where we're looking at today specifically are something's called contour lines. So write this down. So contour lines connect those points of elevation. They show that height of the land, right? And something that's really hilly, the landscape changes a lot in vertical. They're going to have more of those. Flat areas are going to have a little. So look at this one, for example. So this was printed off and given to you. It's somewhere in your documents. But you can see here, really paying attention to this, that, oh, so between this distance and this distance here, this is a 10-meter elevation change, right? And then this distance, so first off, look at the first one versus the second one. It's tighter, right? Look at the last one compared to the first one. It's going up 10 meters at a time, but because it's going up much more rapidly, it's much more steeper. It's a shorter compressed distance, right? So I know the more of these I get, the steeper it rises. So that's what this is meant to show. So this is meant to represent this 3D object in a 2D shape, okay? So really pay attention to how this was drawn here, because at some point you're going to have to do this. Okay, so again, that's what contour lines are. So oh, that's not really relevant to us. So here's your goal: is that you're going to be trying to understand what sea level increases are going to happen. And that's where we're going with this, because last time we talked about glaciers melting. So this is what I want you to think about here is, so what would be some of the changes that have happened if the glaciers of the world melted? As you guys discussed last assignment, well, just directly, does it directly affect you? Well, crap, that's where we get our drinking water. That's where our farmers get the water to water their crops. So that directly affects you immediately. But what if that wasn't the case? What if, even just outside of the water, how does that affect Canadians, for example? Well, sea levels rise, which means we lose land. You and I in Saskatchewan, it's not going to happen to us, but people along the coast, absolutely, it's going to happen. In the next 100 years, we're going to see hundreds of millions, if not over a billion people who are going to be misplaced because the land's gone. It got overtaken by water. And a lot of that's because glaciers and other frozen water is melting. So I want you to think about, and just pause the video for like 5 seconds. What are 5 predictions that you think would happen when all these ice caps melt? 3, 2, 1. Often we're going to see floods, rise in sea levels, increased temperatures. How are all these things going to change? Is it going to happen really quick? Is it going to happen really slow? Is it going to be something you see in your lifetime, or is it going to be your children or your children's children? Is Saskatchewan going to get the same thing as Manitoba or Quebec or Vancouver or Newfoundland, and so on and so forth? So I do want you to get this down. So here are your impacts of climate change. So this is the impact of climate change in Canada. There's a lot here. I'm just going to read the bold stuff here. The expectation is as you write this down, you're getting this. But generally speaking, our growing season will be warmer and longer. Navigation is going to be improved. So there are some pros for us here in Canada. There will be a shorter and warmer winter, but the sea level is expected to rise, and that's going to introduce flooding and erosion to a lot of places. There's going to be much higher risks of forest fire, as those of us who've experienced summer can see. We're going to see much more drought, much more larger insect infestations. We're going to see our fisheries at risk. There's going to be threatened water resources. What does that mean? That means you and I might run out of drinking water, right? That's something we talked about last assignment. We're going to see increased frequency of extreme weather conditions and heat waves. So here's where we're kind of at right now. So these are generally the numbers that are output. So there's a bunch of different ice sheets in the world. If the East Antarctica ice sheet melted, there's about a 65 meter, sorry, do write this down, 65 meter increase to Canada's coastline. If the west one melts, it's an 8.5 meters. If the Greenland's one melt, and all the other ice caps in the world, except for Antarctica melt, we're about a 7 meter. So we combine these 65 plus 8.5 plus 7, we're at an 80 meter increase in our coastline. An 80 meter increase. Uh, what does that look like? Well, this here is a website that is in the link here from below. This is the flood map. Let's go plus 80.5 meters. And let's see what happens. Oh, can't do that. To Canada. Doesn't look like much at first until we really start zooming in. Oh, all of this goes away. Oh, but that's in like a place with not a lot of people. You know, how does that really matter? Ah, crap. There goes our capital. Ottawa's gone. Here's the parliament. Bye, parliament. You're gone. Here's Montreal. Gone. Newfoundland. Most of it's still there, but most people are on the coast. Gone. All these people are gone. Was it? I was just at St. John's the other day. Gone. Well, what about the place where you have a map for, right? Because that's what this assignment's really going to be. What about Vancouver? What happens to Vancouver? Pardon my French, but oh shit, it's gone. Okay, so that's the worst case scenario, right? 81 meter increase. Let's be more realistic. I genuinely want you to do this. If 81 meters is this doomsday, what's a more realistic projection? In 50 years, what do you think maybe the ocean level will rise by? 5, 10, 20, 40? 40 is half that. Is it going to be 8? 8 is only 10% of that. You know, let's be really conservative here. I want you to think of a number, and by all means, go to this website and do this. I'm going to go 25%. What happens if it's just a quarter of that? So 20 meters. What happens to Vancouver? Ah, Vancouver itself isn't gone, but ooh, there goes Richmond. There goes Delta. That's all gone. Surrey, these guys are cut off now. Surrey's starting to get flooded. Langley's starting to get flooded for any of you who've been there. North Vancouver, the airport, gone. Dude, that's just 20. What if it's even 10? Oh, that's 5. Okay, not as bad once we get to 5. But the point of this being is that it doesn't take a lot to really completely decimate a city. That's the main point I'm trying to go with here. So what we're going to look at is you're going to actually draw this in. You are literally going to take your map and you are going to color in, you're going to black off all the stuff that gets washed away with an 80-meter sea rise. Now, how are you expected to do this? Well, that's what this map is for. Now, this is going to be a little bit tricky to kind of pull off, okay? But that's why we're doing this. It's a way to practice. So, starting out here, here's our harbor, right? So this area clearly is water, right? So we're going to assume this is sea level. We're just going to go, this is our big flat 0. This is 0 meters. So what happens if I go up to 20? Well, you would follow along this line. You'd color that all in. There goes a highway. What happens if it's 40? Same thing. You would color that all in. Gone away. And 60. I've missed the line somewhere. Oh, sorry. Here's the 40. Here's the 40. My bad. So here's 40. Here's 60. Here's 80. And then big bold line is 100. We're not going up to 100. So you would find the 80-meter mark, and as best you can, you know, it's not going to be perfect. You might make a small mistake. It's a low quality map for a reason because I have to fit it on a piece of paper for you guys. But you're going to go there, you know, you're just going to follow along, blah, 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 blah. Get rid of it. That's what I want to see. And that's what you're going to take a picture of when you guys are done, okay? Which is looking at what an 80-meter increase is. Now, you don't have to do this. You don't have to go straight to 80 meters. If you're just like, I call bullshit, It's not going to be 80 meters. It's not going to go up that much, and it very well might. You know, is every bit of ice on the planet going to melt? I mean, maybe not. Or you know, maybe at least not in the majority of your lifetime. But what if it's, you know, just 20 meters, for example? Maybe you're just looking at something like that. So you're welcome to start at 20 and then work your way up to the 80 figure. But just do your best with that. It's going to be a little confusing. You're not given a super detailed one here. Um, so just do your best. You might want to even, in fact, use this map here, but this is just to show you how quickly this elevation changes here, right? Again, 20 meters, 20 meters, 20 meters, 20 meters, 20, 20. This little part here, 20, right? You can imagine that that just goes like that. All right. So with that said, I'll let you guys get at it here. If you have any questions, please let me know. Yeah.